Hey, again, just a note before proceeding. I noticed while watching the last video, quite funny actually how it came about. That point where I was surprised that this compiled was on a surprise, and in fact it does not compile. You see, what had happened, I had an annotation. If you have annotations off, you might have missed it. I had some array like this, and then I deleted one element from one of them or something, and that didn't compile, as I was trying to demonstrate. And then I went to put the argument back, like this, but I didn't put the comma back, and then I deleted one of these, and now they're still the same signs. So it compiled, and that was why I was surprised. But the reason it compiled was not because it only copies the first n elements, but because they were in fact the same size. If you look carefully at that video, you'll see the mistake. I just didn't notice at the time. Now I would like to proceed on to our linked list. Let's start up. You won't be confused about which main is which. Now, what I've done with this list here is before I go on explaining it, is what I often do in cases where I'm not sure exactly what I want the interface to look like, is I check and see what the MFC version of the particular thing is that I'm trying to make. For strings too, strings, and what have I changed here? Oh, I changed this to PV dots. That's maybe more understandable, huh? Pointer to the dots. And so I did. Their thing I know is called SeeList. So I F1 on that. Now the reason why I'm always looking at MFC is because a lot of their stuff is really good. The only problem with MFC that I have is that when you want to use one of their great utility things like this list or the string or so on, you got to include the whole of MFC, and I don't want all of it. I just want little bits and pieces. So then I went to look at the members, and I simply since there's not that many members, I clicked on each one. All right, I didn't implement this block size or anything, and looked at what it was, and I copied all these prototypes, and just went ahead and implemented a class that with this almost exactly the same interface. A lot of people don't like the MFC version of these containers, and they have various objections. It uses ints instead of like real manly stuff that the STL uses. The god awful mess they've produced. It's got if it's the STL list. Let's see what theirs looks like. Standard list. We don't even have standard list. List. They must have a list. Oh, I'm probably not including it, maybe. I know they have a list. I know the header file name is called list. Let's see if it comes up now. There we go. Okay. Now you'd think, by looking at this thing, that it's not so bad. Look, it's only got like 4 functions. Well, hang on a second here. There's got to be more to it than that. Oh, here we go now. Now, some of these things might be sort of useful, but nobody ever uses them. I can guarantee you that. But the worst thing of all, the very worst thing, is all this stuff to do with these things called iterators. Iterator and const iterator and const reverse iterator and iterator begin. I wish I could show you an example just how horrific it is. Maybe just by looking at the code. Can I get there? See, now this is a class here, a class declaration. Somewhere in here you should find the actual name. So I wonder where it is. I know that here that's something class template. What's it called? List? No, that's not it. Let's see, list val alec underscore equals list ptr. A bunch of type defs. With alec ref vref node pointers. Anyway, it's pretty much unreadable, right? As it stands, just looking at this. Okay. And when you're trying to step through your code and you're looking in the debug window, it's even worse. Because all these names come out. The name of something starts from this end of the window, and here's the end of just the name of a variable. And you can't say oh, just size. It has to be standard : list of my type : size type equals. It's horrible. And I know I'm just ranting here, but really, SeeList, the MFC stuff, is what I would call like programming for the practical man or something. But I don't want all of MFC. Here probably the one reason why people say the STL is so much greater than MFC is the one reason why I know that MFC is so much greater than the STL. And that is this map. They have a map. You know what a map is? It's a kind of like a tree type structure, okay? And there's one called CMap. And it takes, I think, two, like a key value and a map is a type of thing that you use with square brackets. Map of, 5 equals 9. It looks sort of like an array, but internally these can be any types of objects, and they're stored in a tree type structure. Now the CMap only allows certain types for the stuff that goes in the brackets, right? And in particular, it doesn't allow you to put strings in here, which most people want to have a map where you can put a string. Well, that's not entirely true. You see, it's instead what the people that designed MFC realized. But yes, it's true that sometimes people want want to specify strings in here. My my bills or something. I want to retrieve things by name in brackets and set things by name. But instead of just generalizing the map class, which uses a simple hash algorithm for its tree sorting and everything, and making the STL type version of map, which is horrific, unreadable, but it allows you to do anything. You can put any kind of object in these brackets. They just made a special case called, C map string to object, right? Because it turns out there are no other cases other than string in the real world where people want to put something other than some type of numeric value in here. That's the only case that ever comes up. So why totally generalize a thing and make it impossible to read and manage when there's only one specific case where anybody wants anything special in here? So we'll just implement that one case. That's being reasonable and practical and ending up with math that's usable for ordinary types in the brackets, and in the one weirdo case that is used, they have something for that too, and you don't end up with the mess. But other people may disagree. And I say, yeah, but their map doesn't include. Anyway, now, so I had a look at their class, and whoops. And the interface is okay. That's the private stuff. The interface is the public stuff, and it's things like add head, add tail. You saw it in the help here. Right. It takes their template thing takes two values. You can override this default second value, but I didn't add the second value. That's for argument type is when you want to refer to an element or search for an element in the list. What type of argument should you supply? And a constant reference to the type of our argument is what people always use. So I just use that. So my version doesn't have more than one type to it. I could put that same thing in with a default. I could add another parameter here because there are defaults. Class. What was it called? Our type. I could do that, but I'll never use it, so why do that? Okay, now then there's things, if you look at the members again, all these things involve something called position. And I wasn't sure, but I've used the SeeList before, and I know how it's used. And basically, it's kind of like a handle value, and I thought it's probably just equal to a pointer to node, right? Cast as a void star or something like that. So I had to look at their code, and that's exactly what they do. I have their code somewhere in here. Where'd it go? Somewhere. You can look at all this code, by the way. It's all open source. Although I didn't copy the code because I didn't want all of it, and I wanted to do it my own way and make sure that I understand what I'm doing. I never copy other people's code unless I fully understand it. Where's position? Yeah, see here. They're just casting a node as position. No problem. So that's basically what I did. Now their position thing, though, as far as I can tell, it's as it was before. It has nothing to do with the type of object. Position pause. Yeah, it has. Yeah. Okay. So their node things are different from the way I define node. I wanted to include within this position thing the type, so that you don't use the same pause value on the wrong list. That was one of my concerns, that you might pass the wrong a pointer belonging to one type of list to another type of list, and I don't want that, so I didn't use their type of position. I defined mine in this way. Using this declare handle is just a way of making a type out of a name into a type. It just uses a dummy struct and then type defs it. Okay, so this is nothing more than a typed pointer to void. Okay, so it doesn't. There's no data in here. It's just what they call a handle, and I call it position, same as their position, and somewhere or other I may have turned it into a number. Here we go. Here, just like they did, I'm casting things to position types, which are p voids basically. Now to use the thing, I've lost my name. No. What is this? Oh, there's no code. Oh, there's no. That's true. That's true. All the code's in the header file because it's a template, and so unfortunately, you got to put all the code in the header file, unless you want to write down specific versions for every specific type. And that's one of the things about templates that bothers me, and I don't know if there's any solution to that. Basically, you got to code everything in the header file. But the usage is quite simple. So here I have a list of strings, okay, and I'm using that string app. And I've added, they don't have this, I added a plus equals operator. So I'm adding, this adds something to the list. I renamed their version of this function is called remove tail. They have remove head and remove tail, but to me that doesn't indicate the fact that those two functions not only remove an element, but they return the removed element. So I changed it to pop head, pop tail. That's why this here has removed an element from the tail. The position thing, like I said, changed. It has to be more specific. It's a position related to lists of strings. So this position thing can't be used for a list of integers. And I want that. That's what I want. The data is hidden in the sense that it's, as far as this definition is concerned, it's hidden. You could cast and get away with mucking around with these numbers, but you'd have to do it on purpose. The reason for the hiding is not to prevent people from access, but to prevent people from making mistakes. And as far as the interface is concerned, you won't make a mistake if you use the interface. This gets the head position, okay, which happens to be a node, but you don't need to know that. Otherwise, if there's nothing in the list, it returns no. And then this is the standard loop you go through to iterate through a list. While this is not no, then to extract a value at the current position and at the same time advance to the next position, you use this function. So this is actually a reference to a position passed in, which gets incremented when you call this function. So for instance, if I actually compile this, should compile. Okay, first step up to here. First I'm declaring a list, which just sets some values to null. And now just 10 times I'm adding 10 different strings to the list. And this is a bi-directional list. So it has a next pointer and a previous pointer. This is add tail. Now this new node is sort of like our alloc node as we had before. And it does nothing fancy. It allocates a new node. Okay, node is defined right here. And T is the type of data, strings in this case. So that means that now that this node, okay, contains well, 2 pointers in uninitialized and a data member, which is currently null. Now these values get set similar to before, and the first one in the list. There's a count maintained, and the node is returned. So now we have a new node. Doesn't have anything in it yet. And now this setting of the data is just by copy. So if the object has a copy constructor, which ours does, and I'll hit F8 here, you'll see where we go. We're now in the strings copy operator, not constructor. So now this node has a copy of that string. And now we return the position of the node. Turns out that that's the return value. But I'm not returning that. I'm returning a pointer to the structure. Okay, so we do that 10 times. Here's the list. There's some space here. Okay, there's here's the data. The number is 0. Here's the next one. The number is 1, and so on. And next, and these also have previous pointers. They have next and prev, so you can easily add to the head or the tail and easily walk backwards or forwards. I haven't implemented every function. Now for iterating, oh, by the way, as you can see, I popped the last element. So now the list size should have gone down to 9, which it has, and it's missing the last element. The tail node is, the number is 8. It used to be the number is 9. Okay, now get head position is what you would expect, just returns that first node. And this thing, well, I turned this into a macro. Pause here, that's a position, it's cast to a node. The data is stored in a temporary variable. The node position is incremented, and then I return the temporary variable. So there is a copy here, maybe unnecessary. I could have made this a reference, I guess, to avoid it. Copy. Well, better to leave it as is. Works. I'll write it out. That's that. And keep going. And it'll go through to the end of the list. All the way to here. The list is still not empty, but it has a destructor. And first this string got destroyed, and now the list is going to get destroyed, and that puts you in here, which frees all the nodes, and then we'll go through it. No memory leaks or anything. And we have a list class. These I haven't implemented yet. I don't know how much more there is to say about it, other than you can look at the code and try to make sense of it. Once I upload it. Also added this macro, this iterate macro. This is forward iterate. Now I don't know how much time have I used. Okay, I have enough time to explain this. There's a trick, okay, and it even has a name. I can't remember the name of it. It's a common situation that one comes up with, where you sort of want to do something like if some function, suppose some function returns a number, and if the number happens to be 6, you want to do something, and what you really would like would be to say if int some variable equals function, do something with that variable, blah blah blah, and then go on with the rest of the code. But you're not allowed to do that. Well, I don't think you're allowed to do that anyway. You can declare a variable here. Oh, but you can't make a comparison. That's the problem. See, what you do want to do, you're allowed to do this, right? But then I want to be able to further add, equals 6. But that you're not allowed to do. But wouldn't it be nice if you could do that? Then you could use this variable and not have to do what you always have to do, is invent a variable that's defined here, used once, right? And for the rest of the scope of the function, this thing is existing for absolutely no reason whatsoever. Nobody else is using it. Your only intention is to use it in here, and only in this case. Well, there's a trick that allows you to do that. And the simplest form of that trick is this. If bool b once equals true for Now int, what did they call it? The var? The var equals some func b once. And there you go. Okay? Now, you're allowed to do this. So this condition is always true. Nobody will ever see b once outside of this declaration. Here, you've defined a variable, the var, and set it equal to the value that you wanted. This is a for loop that quits if b once is false, but it's not false, it's true. However, by the time you hit this spot, it goes to the thing that it always does at the end of a for loop, which is set b once to false. So the next time it hits this statement, it's going to quit, and you've got the thing that you wanted. And there's a name for this trick, and I forget the name. And I use that trick actually twice two times over in this macro. I want to get the count. I need the count of the list. I need the head position, and I want to invent a new variable name and iterate through the list. Doing get next, except for on the last element, I don't want to do a get next, which is why I needed this count. But nobody has to see any of that. It's just this way. I've written it as just iterate here for simplicity. Iterate. I better use this to get the argument list at least. Type is string, and then my list, and the variable name, stir. Now I can change it back to what I wanted. Let's see. This is all hidden. Nobody's ever going to see a stir anywhere, and you don't see the pause. And I don't have to declare anything outside that anybody has to see. There's a hidden list of string pause somewhere in here, but it doesn't exist by this line, nor does the count variable that I created, and so on. And I can run through it and it works fine. It does what it did. And if I pop the last element as I did last time, I haven't tried pop head yet, so do this one I know works. Actually, I have to do this. The tail will be the 9. So we get the 9 and then count up to 8. Anyway, so those are two things that are quite useful that you might want to remember. If you're wondering what's a good interface for a container type class, check the MFC help and see what their implementation is. It's probably best to do something similar to theirs. Not only is it easier to use, but people who are familiar with MFC won't be surprised and will have no problem understanding what your code's doing. And secondly, that nifty trick that has a name, and I can't remember it, of being able to declare and conditionally use the variable in one single statement using a macro, using this type of assignments, and then followed by a for loop, typically with a one-off count. But in my case, I want to go through an entire list of things, and that's it. Okay, well, I guess I don't need to say more on it. I'll finish up the rest of the implementation. I'll upload this before finishing it, so that you could try maybe finishing it on your own. Okay, see you.